And we're live on another episode of this show, and I'm digging this, Christian. I'm enjoying server mess of the developer. Somebody was that my wife?
That was my wife. She just she says hi.
Bless her.
Yeah.
But I'm really enjoying the I'm really enjoying this series. I kind of I'm having a lot of fun, and I'm really looking forward to today because I think last week we kind of covered a lot of the things about what does it mean? Why do you need a service mesh? Why should a developer care about using service mesh? And I think there's a lot of really good reasons why. And of course, folks can watch that video. We'll stick the link down below to the previous video. But today we're going to start looking into API Gateway, and you've got a wonderful demo for us, and we're going to kind of look through that. We're all pretty much 100% live coding in this episode, which is going to be exciting. For a little bit of recap, if anybody's new, what we're doing is service mesh in the developer workflow. So we're looking at things like API Gateway, Canary deployments, how to do debugging and tracing, remote debugging to your local machine, using some of the fantastic solo tools, Consul Connect, all that goodness, and Kubernetes.
Yeah,
so
absolutely. I mean, the premise of this is for developers, right? So we hear about API gateways, service mesh, these types of tracing, this type of stuff in terms of, well, that's all operational people. That I don't really need to worry about it, but I think there is a lot of value that it brings to simplifying the lives for developers. And we'll as we've started talking about it in the previous episode and over the next few 4 or 5, whatever the number of episodes we'll end up doing, I think it's pretty useful.
Yeah, I mean, like some of the sort of the discoverability elements. I mean, sort of debugging and tracing, just absolutely essential for your day-to-day workflow. And I think the key thing though is that everything ties together. Like you can't do debugging and tracing unless you get a handle on how an API gateway works. I mean, that kind of might feel weird to a lot of folks, but it really does matter. And I think we can also explain that it really just isn't that hard. It's kind of it's stuff that a lot of people can manage. You don't need to have an infrastructure background, or you don't need to be particularly operationally minded.
Right. As the cloud native platforms are built with a bunch of, if you look at the CNCF, for example, it's a collection of projects that fit together and come together. And what I'm sure Hashi is focused on, and what we're focused on is there are going to be these moving pieces, but how do we simplify that? How do we make that easier for people to consume, whether you're on the operations side or the developer side? And hopefully we can explain some of the things that we're looking at throughout this series. So I think it's good. I'm excited to help do this.
So you have a compliment on your collection behind you there.
Yeah. I like to collect and at times sample. So appreciate that.
I mean, I think an interesting fact for any of the viewers that they're probably looking and saying, well, most of those bottles are really full. They're not. Christian has totally drained them. That's tea.
I put water back in them and just water and tea. Yeah. Those are the empties.
Alrighty.
Maybe we should do this one day in live when you come down to Phoenix. So I'm in Phoenix, and you're in London or the UK area, but yeah, come down here and we'll do one of these live.
And then we have to do a shot every time somebody says service mesh.
Yeah, exactly.
All right, that would be fun. Should we begin? Have you got a demo for me?
Let's get going. Yes. Yep. And so let's pick up where we left off. And just to recap, this is based on material that we put together and attempted to deliver at KubeCon. The issue was at KubeCon was we were overloaded with the number of registrants. I think it was like 900 or something. And then the actual people that showed up was like 400. And so it was difficult to run this workshop at the fidelity that we wanted at that scale. So we're scaling out by doing this. Now, if you look at this is the material, and last episode we started to walk through some of the setup using the fantastic tools that you've built Nick, the yard, shipyard tools to help package everything nice and neatly. There's also at the very top the instruct environment. So if you look at this link and click on that link, it'll take you to a fully built environment that runs just through your web browser. You don't need any extra tools or anything. The shipyard tool you run on your laptop and uses Docker for desktop or any Docker daemon really. But so then we started to poke around. We looked at the things that it bootstraps and sets up, the dashboards that you have access to, and then we started to dig into, right, we have service mesh, with Consul service mesh set up, we have our development environment set up, but then to run through the rest of the developer focused material that we have, we also need a way to get traffic into our cluster. And that's where we started to install a gateway, an API gateway that works very nicely with Kubernetes called Gloo. And so that's an open source project that we have at Solo. And what it is an API gateway built on Envoy proxy. And Envoy proxy happens to be the overwhelming dominant proxy in this application networking space. A lot of the service mesh technology, all the various ones, including Consul service mesh, are built on Envoy.
And Envoy's crazy fast, right?
Yes, Envoy is built in C++. It was implemented to solve these proxying problems at the edge, and versus sort of the way we had done things either in the past with I'd come from a Java background, and we used to build this kind of Java infrastructure, or this sort of networking infrastructure in Java. And even at Twitter and Netflix and so on, we saw the evolution of their tooling on things like service discovery and client-side load balancing and edge gateways and this type of stuff. They're built on Java. And some of the downsides to that is that at high scale, and you have to keep certain SLAs, that the latencies, the tail latencies, can be kind of all over the place, because the Java JVM will just say, all right, I'm done, I'm taking a garbage collection pause right now, right? But with Envoy, purposely built with C++, a language that can help control some of that, allows much more defined and better tail latencies. Yeah, nice. So it's fast, it's slim, right? So if we're talking about this at a service mesh level, when the proxies get deployed with each application, we don't want them to be super resource hogs, like especially overshadowing the application. We want them to be kind of slim and performant. At the edge, we also want very quick, how to just get traffic into our cluster with minimal fuss. Although at the edge, the problem that we're solving is slightly different than when traffic gets into the cluster and services are communicating back and forth with each other. And we can probably more generally say at any boundary, there's probably going to be these different concerns, like, for example, security. A security model will probably be different at the boundary, at the edge, when you don't know exactly who's trying to come in and communicate with the services inside your cluster. And then there are other things like the stuff that's inside your cluster. You might want to expose that outside the cluster without revealing the implementation details of exactly how the services work, or the protocols, or the messages, or whatever, right? So there's a layer of abstraction that you want to achieve at that boundary, which calls for a slightly different take on what that proxy should look like versus what the proxies look like inside a service mesh.
But one of the things that I'm really, really interested in, and I think we will be able to show some folks, is that it's accessible. I mean, mm-hmm. I come from a developer background. You really wouldn't want to trust me with administering a Unix server or anything like that. I can kind of work my way around an apt or maybe do some basic systemd, but software development and architecture is my background. the thing that I've kind of found around configuration of API gateways, and whether they're sort of cloud or whether they're software or hardware based, is that it's always just been something that I'm just not particularly keen to dig too far into. It's kind of just feels a little, but this is nice. This is accessible, and I think this is important, because a developer, I should potentially take some ownership for the routes which are related to my application. Like, you could take
Absolutely.
that as certainly sort of being able to make some sort of configuration and tweaking. And if I can do that fast and I can ship features faster, everybody wins.
That is such a core part of a workflow that you build when you start to go to a microservices style architecture, right? Because if you think about your environments today, or even in years past, you would have, this is the enterprise service bus team, or even not long after this is the API management team. And when you wanted to expose an API, you would have to go to that team and shuffle around all the details, and each person or team that wanted to expose an API had to do this. You had to all come into this centralized way of onboarding and administering and so on. And if you think, well, let's fast forward to today, where we're talking about microservices, where back then there were APIs, however they were built and deployed. But now, if we're going to do microservices, there's going to be more. There's going to be a lot more of these things. Now, that's just going to there was already tremendous pressure on those centralized teams. Now we start saying there's going to be more of these services that we need to expose. It just doubles or triples or even more the pressure. So what we're hoping to do is find a workflow that in a real enterprise suits the demands and regulatory compliance and so on that an organization has for the parts that need to be centralized. So like security, especially, right? Security, change audit, and that kind of stuff. And decentralize the parts that you were just hinting at, that the developers care about. The routing prefixes and how they match to get traffic into their service, and they might want to do some light transformations or reshuffling of the messages to get into their service, or the responses that get sent back out. So those sort of capabilities and features and functions, if you can delegate those to the individual service teams and developers, they can go about their business independently without having to file a ticket and have these synchronization points which cause issues.
I like
that. Yeah, and that's kind of that self-service model, or that independent model, is what helps you truly get the value out of a microservices architecture, right? Because just having the services smaller or independent doesn't buy you anything if you can't independently move in parallel, right? And if you have to come back and have these synchronization points, then it kind of undoes some of that value. So let's take a look. Let me show you. So with if we follow this guy, we install our Gloo gateway. We have some of the control plane components that will help support running the Gloo API gateway, and the gateway proxy right here that I'm highlighting. Right, actually, we could just go to go here. If I do in the Gloo system namespace, we can see the gateway proxy here, and if I do something like if I do something like just list the processes from this pod, we can see that there's some bootstrapping code, but this is Envoy. We see right. Envoy is one of the processes here, and its configuration.
And of course, you're just running on your laptop in a dev environment here, and you've got a single instance. But I'm guessing that the gateway proxy is massively horizontally scalable. So no matter what the traffic demands on your ingress, you could just keep scaling this almost infinitely.
That's correct. And So Gloo specifically uses custom resource definitions. So we're running in Kubernetes here. You can run outside of Kubernetes as well, and then the structure and the schema of the configs would be the same. You just would have to store them not in Kubernetes, right? In actually HashiCorp Consul, we support very nicely. But inside of Kubernetes, we use these custom resource definitions, blobs of YAML, to declaratively configure the the various APIs and routing rules and security and that kind of stuff that you need. And then the Gloo control plane here takes that API surface and translate that down into the config that Envoy understands and gives that to Envoy. So basically, if you can scale out Envoy as much as you want to meet your traffic demands, and then the control plane serves the config to those various proxies. Yep. Okay, so let's take a look. Right now, if I do Gloo control get virtual service, we should see we don't have any virtual services defined. A virtual service in Gloo is kind of the object that you use to define what the API looks like outside of the boundary, in this case, the Kubernetes cluster. So we don't have any of those right now.
And this can be any service that I've got running in Kubernetes, or
yes, right. So I have right now I just have a very simple Echo server. So if I were to call it, I would just get the details of what I used to call it, right? So just respond with what I sent in. So what we're going to do is we're going to take a look at a fairly, I don't want to say simple because it's not just hello world, but it is a little bit, so there's a little more structure to it to give the sense that there's multiple different APIs that we might want to support here. All right, so this is a virtual service, and we're going to match based on certain API paths that come into the proxy, and then we're going to route them to various backends. So in this case, I have an API called check card, or loan status, or risk screen. So this is kind of banking focused, but it could be any of these.
So just one thing on this pattern, which I'm kind of digging here. So theoretically, you could have an API which is made up of a number of different microservices. So kind of like conceptually, it is performing a single task, but from a kind of a code level, it's broken of many different levels. Can I also use API gateways in this way to kind of maybe break down any monolithic applications? Is that a sort of a feasible pattern?
Yes, absolutely. So you could say a monolith might have a certain number of different network calls that it makes. It'd be nice if they're nice REST calls, but they're not always, right? Yeah. But so you could use the gateway to stand in front of the clients. So let's say this is a monolith that the UI is calling back into this monolith to get various data and functionality and so on. But you could put the API gateway in between the UI and the monolith, and basically proxy the monolith calls as they are today. And then incrementally, when you're ready, and maybe you're going to strangle the monolith by adding new services around it, or maybe pull functionality out of it as a standalone service, you can use the gateway to control, okay, this is going to the monolith, and for this percentage of traffic, we're going to actually send this to the new, the part that we've ripped out, or a new piece of functionality. So you can use the gateway to slowly roll and canary various different changes that you're making in the back end. So if you start with a monolith, you might go to a microservices architecture. Yeah. If you already have microservices, you might be making changes to the microservice, and the gateway gives you a point of mediation to allow you to control that at the rate that you're able to consume.
Nice. And on Canaries, I know we're going to cover that in I think about a week's time or so. So in episode 3 or 4 probably, which is going to be nice. Sorry, I will stop interrupting you.
No, those are all great questions. But then so this fairly simple virtual service, let's go ahead and apply it just to make sure that that it takes, first of all. So that looks like it didn't complain at least. So let's get virtual service from our tooling. We should see that it was correctly accepted and that we now have these various different APIs. If I do proxy URL, it'll give me the public facing URL for this particular cluster. If I come over here to Firefox and go to it.
So that's quite, so just
Yep.
on the Gloo CTL tool. So as a developer, I can just have that running on my my laptop. It's just kind of a nice, actually,
yes.
way of interacting with and interrogating the API gateway.
Right. It's an optional piece.
Right.
So far everything I've showed is driven through Kubernetes YAML files, but it's an optional convenience CLI that allows you to add routes, change routes, quickly see the debug logs, quickly see the underlying configuration inside of Envoy, and so on. So
whereas I might have a more formalized workflow for my production environment,
right.
for my dev environment, if I want to kind of do some quick changes, then that's actually a really nice way of doing it. I can just hack away with that in my terminal on my throwaway dev environment. Nice.
Exactly. So we can see if I click refresh, we can see that I'm getting, each request is changing, and I'm hitting this, ultimately the echo service, but it's going through this API that we define on the virtual service. Now, one of the challenges which we started to allude to is when you have, for example, multiple different microservices here that you want to treat individually and kind of offload and decentralize the management of the routing rules from the things that the developers are interested in kind of tuning and tweaking and changing versus what the operations or platform teams are very worried about, right? So if we take a look at, actually, let's come over here if we go to Gloo documentation, and if we look at the routing section in Gloo, and then the virtual service. So the virtual service object is what we started to look at in the configuration. Like I said, this defines the services that are actually exposed outward.
Right.
If we click on virtual service, we can see that there's a section here on delegation. And what delegation allows us to do is achieve that separation. So the API that Gloo gives you and allows you to use to configure Gloo says virtual service, yep, that's where we define the domain and the routing rules and security and all this stuff. But for developers, we'll allow you to delegate the routing table and all the details that developers care about into a different configuration,
right,
which is called the route table.
So I like that, and I think Joe in the chat actually had a really good comment, because Joe was kind of one of Joe's comments, which I've heard myself. I think it's perfectly valid. Is that some devs just aren't interested in this? They see it as kind of like an opsy thing, and it's just not something that they want to do. But I think kind of something like this makes it simpler. It can be more appealing to somebody. I like that.
Right.
It's nice.
And so the routing table through this delegation that I'll show is optional, right? Because you could just do this, and if you want the operations team, platform team to just take care of all of this stuff, that's fine. Put it all into the virtual service.
Right.
And if we come back and look at this this one, so rewrite that uses the delegation, this basically says, hey, on any API/risk screen, delegate that to the routing table that applies to risk screen. Now you can conceivably think, all right, that part of the configuration, which we can just find right here, this route table config, this could live with the applications.
Yes.
This could live with the developers. Now they have the autonomy and the ability to influence the behavior of the parts of the gateway that the platform team has delegated. Right? And that would include things like matching and routing and retries, and transformations, message level transformations. So these are things that the developers would be more inclined potentially to own. Now, if they don't want to, this API is not forced on you. It's an option.
So that I think that's really nice because it gives you the opportunity to put this configuration. I like things living with my app that should be controlled by my app, and I can put it as part of my CI/CD, which again, I personally quite like the control. You mentioned something there which I think is interesting because you said message transformation.
Mm-hmm.
Can you talk to me about that?
Yeah. So as part of exposing your API on this gateway at this boundary, right? We touched on this earlier that I might implement my service a certain way, and maybe I've written it in gRPC, or maybe it is a JSON REST style service, but the way we expose it, we don't want to expose certain headers that the client needs to know about, right? But the service, when it's called internally and so on, or probably internally is the best example. They will be able to make the calls directly to the service. But when we expose things outside, we want to present it a different way. So for example, if I actually click on the risk screen routes here and look at where I did actually add a transformation.
Right.
In this case, we're saying, when you call this risk screen service, I need to have a particular header, or I need the body, maybe a little more advanced, I need the body to be in this particular shape, which is different than what we're exposing to the clients.
Yeah.
Right. And so now when you do it, first, now you're decoupling your API from how you've actually implemented it. And in this particular case, since this is in a routing table, the developers are owning exactly what that transformation looks like, instead of like we did in the old days where we said, well, the integration team will take care of that.
Yeah. But I like that. I mean, I can see a number of different uses. One which really sticks out at me is things that I can't change. So when it might be an internal team, I could just work in a really big company and I can't get a cadence around an API contract, which I'd like changed. But also, I think one of the most common use cases is when you didn't actually write the software. You might have bought a piece of software that you're just running inside of your estate, and like depending on how old it is, or you can't always guarantee that it works. The interface is as you would like it. This seems to be quite a nice opportunity to put that sort of logic in here as well.
Yep. So we decentralize the control to the developers where it makes sense. But then on the other hand, so for example, if I come over here, and I'll actually deploy this one, so we're not just gazing at YAML. But so we have our matchers and our delegation in the virtual service. But the owner of the virtual service, likely a platform team or more centralized team, will want to control things like, well, at what domain does it get exposed? What are some of the security? So for example, in this case, we're going to enable OpenID Connect. So what are the security flows? What do those look like? What are the rate limiting parameters that we need, and so on? So like if I deploy this here, first of all let's do route table. We'll do transformation. Let's apply the various route tables first. And then what we're going to do is we're going to deploy the banking OIDC. So we'll have the full separation where the developers in their route tables, they have the routes defined, the transformations defined. On the virtual service, which is delegating, the virtual service itself will have its security defined, its domain defined, rate limiting, whatever. So if I apply this, and now if I come back here and try to hit our service and refresh, I should be forced and challenged now because the security had been implemented, which the platform team owns, let's say. I click on that. I noticed this something. Let me go to a private.
That's all right.
A private API. There's something wrong with my browser there. But so if I click on log in I should be taken to the login page, right? Now it's just following the OpenID Connect. This is solo. Next. And
PASSWRD.
welcome 1, 2, 3. And now it should it should send me.
Here we go.
No.
Oh no.
Well, it let me through. Here we go. Oh, what the heck?
But this is cool. I mean, I can.
There we go.
Yeah.
So now we logged in.
Nice.
We can see that we hit the service itself.
Yeah.
And one of we hit risk screen. We noticed in the transformation we added something to the body.
Mm-hmm.
And if we come here, we can see that indeed has been added to the body. So we have a delegation and separation of responsibilities.
Where is the OIDC code actually being handled? Is that actually inside of Gloo itself, or have you got like a service sitting behind Gloo which is handling all of that logic?
So this is how it works. Just real. Oops, not that one. Let's go over here. Let's go to Google, and we'll do Envoy control plane. There's if I find the right one, this would be the right one. In this image, if it cooperates. So here's Gloo control plane driving the Envoy proxy.
Yes.
A message comes in, request comes in, and it hits the external auth filter in Envoy. And,
right.
And the same thing in Gloo. So what that'll do is call out to an external auth server, which is part of the control plane. And then the external auth server will handle the correct OIDC flow, or if it's an OAuth 2 client flow or whatever. So the auth server there implements the details of that.
So in the instance before, you were using Auth0 as a SaaS-based OID provider, but Envoy's actually got all of the logic in there. So as an application developer in this instance, I don't need to do anything other than handle what I do with the sort of the information that I get back.
Exactly. The developer just focuses on the route table here, transformations, whatever. If we come back and look at the OIDC configuration, this says let's look at the OIDC configuration, and this configures Auth0 and the proper client ID and the secrets and all that stuff.
An OIDC, it's a standard, which means that I'm not limited to one particular software provider. SaaS. I could use anything. I think can you even use like Google logins? Yeah. Yep.
Absolutely.
Nice.
Absolutely. And actually, the docs for Gloo's OIDC setup uses Google as examples.
I mean, big shout out to Auth0. I think they've got a wonderful product. So I'm not detracting from that. Just great flexibility there.
Yeah, absolutely. So that's an example of the tooling in this space that we're going to be looking at. This application networking tooling that is very cloud native. It's in this case we're running it on Kubernetes, and it's seamlessly. Some of the other previous generations, let's say, of API management, API gateway, they were step 1, install 9 databases. Step 2, configure them to BHA and so on. But this plugs in nicely and neatly with a model that we're used to, at least if we're on Kubernetes. So do you think we have time for questions or follow-up thoughts, and then we'll lead into next week's topics?
I've been bugging you as I've been going along with my questions. I just can't I can't stop myself. If anybody
appreciate it. It's good stuff.
If anybody in chat has a question, then please by all means just hit them up at us. And also I kind of want to say that whilst we're kind of doing this as a weekly stream, if there's something burning in your mind, you can bug us anytime. We are very, very buggable people, and you can Twitter stalk us. I think we've got all of the details there and the messages there. Now next week, distributed tracing. So I think this is an interesting thing, because I look at service mesh, and every time not gonna lie to you, when I first looked at service mesh, I'm like, this is going to be amazing, because I don't need to learn how to do distributed tracing in my applications now. And that was partly because I didn't necessarily understand how tracing worked. I hadn't looked at it a great deal. But I'm excited about this, because what we're going to show you next time is not only how you can use distributed tracing in terms of the service mesh, but actually how you're going to have, there's no way around it. You need to put some stuff into your application code. Yep. So we're going to run through some samples of what open tracing looks like, and we'll base those examples in Go, because that's kind of where my brain's at. But the nice thing about open tracing's a sort of a package, or what do you call it? A standard. It's kind of a standard, I suppose.
It's a standard, yeah.
Yeah.
Specification.
Specification, yeah. Which runs across a number of different languages. The things you do in one language are very, very, very similar in others, whether you're using Go, Java, .NET, Ruby, Python, Rust, whatever your language of choice is. And we're going to take you through that, and that's going to be exciting.
Yes, absolutely. And then the things that the developers have to worry about, I think that they have to worry about, and that they get value out of in terms of this type of diagnostics and tooling and stuff that we can do to help you understand what's happening in your services architecture when things start to go sideways, and they do.
I do always make a point of saying this. I mean, I genuinely, personally, I don't need this stuff, because I don't write bugs. But I know a lot of people do. So
yeah, and a lot of people don't write bugs too until they just show up somehow.
Undocumented design features, not bugs. It's all it's nothing to do with code quality. It's everything to do with planning or project management or
forward
something
thinking.
Like that.
Right.
Yeah. Right. Christian, I want to thank you again. Wonderful talking to you yet again. I cannot wait for next week. Thursday cannot come around too soon.
I'm absolutely looking forward to it. To the audience, follow us on Twitter. I'm at Christian Posta. Nick, you're at Sheriff Jackson.
That's right, Sheriff Jackson.
And that's also a great way to strike up conversations or follow-ups after this for those that weren't able to join live.
And of course, it wouldn't be a YouTube video if we didn't tell you to like and subscribe.
Please do. The more likes and subscribers we see, the more happy we're to continue doing this.
I want to do it forever. All right, buddy.
All right.
Until next
I appreciate
time.
It. Yep.
See you all later. Bye.